So I am officially recording this right now. We're going to do a review for the quiz 8.1 and 8.3, adding, subtracting, multiplying, dividing, and simplifying rational expressions and graphing reciprocal functions. All right. So we're going to do a couple of each just to let you know what you're going to see on the test. Well, one type of question is I'll give you a single fraction and you will have to reduce it, right? You have to simplify it, right? How do you simplify? You factor anything possible. So the numerator, I noticed that it's a difference of two squares. So I could rewrite it as x plus 2, x minus 2, over the bottom one. I could factor out an x, and I'll have an x minus 2 left over. And you could then cancel out the entire x minus 2 with the entire x minus 2, giving you a final answer of x plus 2 over x. Now, of course, when I make multiple choice answers, I may give you the answer 2. That's a distractor because some people are going to think, oh, I have an x up on top, an x on the bottom, I could cancel those out. No, you can't. Why not? Because there's a plus 2 up there. The only way you could cancel is to have pure multiplication, which is the reason why we start factoring in the first place, to get that multiplication to be able to cancel. So that's simplifying. Let's take this and actually, it's the same problem as you see right there. It's right here. We already got the answer there, but I want to show you how multiplying fractions is really the same exact thing. The only difference is that you do the same thing to the different fractions and then cancel whatever is on top with whatever is on bottom. That's identical. So what I would do is go through each one of these. I want to go through the numerator right here and factor out an x, and I will have an x plus 3 left over. Okay, so I don't need to look at that anymore. I already factored out an x. The bottom one, it's a quadratic trinomial with the a value being 1. So it's as easy as thinking what times what is negative 6, that if I combine together is positive 1. That'll be a positive 3 times negative 2. And then over here, okay, we could scratch that out because we already rewrote it in factored form. And we already did this one on the previous one. That was the difference of two squares plus 2 minus 2, right? What times what is negative 4, that if you combine together gives you the middle value, which is nothing, right? That would be a positive 2 times a negative 2. And if you combine them, it cancels out. That's why there's no middle term. Anyway, the bottom one, we already factored out as well. We're going to factor GCF, the x. You'll have an x minus 2 left over. So we have rewritten every numerator and every denominator in factored form. Why did we do that? So we could get multiplication, and now we could cancel whatever we see identical up on top and on bottom. So we have an x plus 3 up here that cancels with an x plus 3 down there. We also have an x minus 2 up here that cancels with an x minus 2 down here. And we also have an x that cancels out with an x, so that disappears. So what is left? We have an x plus 2 up on top over an x minus 2 on the bottom. And right there, you cannot cancel out the x's or the 2's because there's a plus and there's a minus on the bottom. Can't cancel unless there is multiplication. That is your answer. Let's move on. Let's do some dividing, right? We already did multiplying. Let's do some dividing. It's the same exact thing, right? Same exact thing. Let's first, let me move this out of the, whoops. Let me move this out of the way, make some space. Let's first rearrange things. If they're out of order, you got to get them in order, right? If you have a quadratic trinomial equation, rewrite it in standard form if it's not in standard form already. In this case, we have the minus x squared second instead of first. So I'm going to rewrite it over here, put the minus x squared right there, and obviously that's a positive 9. Let me rewrite it, or actually I could just scratch it out now since I already rewrote it right here. So what do I have here? I have a negative x squared plus 9. Okay, a negative x squared plus 9. And we know that we don't want negative x squares. We want a regular x squared. So I am going to factor out a negative 1. Factor out a negative 1. And what do I have left? I will have a positive x squared minus 9. And then I look at the inside of the parentheses right there, and I see that it's a difference of two squares. So not only do I have a negative 1 out here, but the x squared minus 9 could be rewritten as x plus 3, x minus 3. Okay, so that entire upper left side of this question, the first numerator, changed from the original 9 minus x squared to negative 1 times x plus 3 times x minus 3. Okay, so this is what we really have as a numerator. Down here, we can't pull out a 9, can't pull out a 5, but it is a difference of 2 squares. So we could factor it by square rooting it and plugging it into our factored form answer format. The square root of 9x squared is 3x. The square root of 25 is 5. And of course, one has to be a minus, one has to be a plus. So let me start rewriting this first fraction. The first fraction will have the negative 1, parentheses, x plus 3, x minus 3. And on the bottom we have a negative, actually not a negative, we have a 3x minus 5 and 3x plus 5. Okay, now this division is going to become multiplication, and this second fraction will flip. But as I am flipping them, writing my new fraction over here, I am going to factor already. So this 6x minus 10, as I move it up, I'm going to factor it and pull out a 2. If I pull out a 2, what would be left? A 3x minus 5. And then this 2x minus 6, as I move it down, I'm going to factor it. I'm going to pull out a 2 again, and I'll have an x minus 3 left over. So now that we have multiplication everywhere, right? We have multiplication between the two fractions, multiplication between the negative 1 and the binomials. All these have multiplications. Whoops, I forgot to close that parenthesis right there. We can now cancel whatever is identical up on top and with that whatever is identical on the bottom. So we have a 3x minus 5 up here. That'll cancel with the 3x minus 5 down there. We also have an x minus 3 up here that cancels with the x minus 3 down here. We also have the 2 that cancels with the 2. And that's it. So our final answer will be negative 1 parenthesis x plus 3 over 3x plus 5. This is the answer. Another acceptable answer would be to write the x plus 3 over 3x plus 5, but put that negative out in front of the entire fraction. Or even another acceptable answer, it would be to distribute that negative 1 inside to both. That'd be a negative x minus 3 over 3x plus 5. Now, I would stick with this guy right here. Why is that? Because it's in factored form and I could clearly see that nothing else cancels, right? Anyway, that is dividing, which is exactly the same as multiplying. Not only that, guys, remember, it might not give it to you horizontally. It might write it as a complex rational expression, which is vertically. So you could have the original 9 minus x squared divided by 9x squared minus 25 divided by, and then this fraction on the denominator of a complex rational expression, all right? So if they do give it to you vertically, then just rewrite it horizontally, right? I hope you know what I'm talking about. X over y, let's say divided by 2x over y. Just change it from vertically to horizontally. X over y divided by 2x over y. And then you'd be able to change what we did just now, the division to multiplication, and flip the second fraction. I think you guys get it from there. Wow, that's messy. I apologize. Let's move on. Let's subtract. Honestly, adding and subtracting are way harder than multiplying and dividing because you need a common denominator. And just like on every single one of these problems, it's a good idea to factor whatever you could possibly factor. So on the first denominator, we could rewrite this as a negative 4, y minus 4 times a positive 3. Why? Because negative 4 times 3 is negative 12, and if I combine it, it does give me that negative 1. So the factored form of y squared minus y minus 12 is what we just wrote down there below. So I want to put a line through it. You don't actually have to put a line through it. I'm sorry. Anyway, the other one, let's factor the other one. The other one we have what times what is 8. That if I combine together is negative 6. That'll be a minus 4 times a minus 2. That'll give us a positive 8. And if I combine those together, it really will give me a negative 6. So with that said, we need an LCD. All right, what is our LCD? Our LCD will be and I'll write my first fraction right here, and then subtract my second fraction over here. And my LCD will be, what do we have in common? Let's write it once. Well, we have the y minus 4 and the y minus 4. I'm going to write it one time, y minus 4. Okay. And then what else do we have? We have the y plus 3. And then we also have the y minus 2. And technically, I am supposed to write it twice. Let me do that. However, you know what? I'm going to pause this right here. Not as in pause the video. I'm going to pause the process of simplifying this. What I'm going to do right now is show you like a shortcut. Is it a shortcut? Well, it's just like a different way of doing it, okay? So that didn't work. Give me one moment here. So I'm going to move this to the side. Technical difficulties. So here's like a different way of doing it. You could technically write your LCD one time and then put all of your work on top of this one LCD. Now, what do I mean by that? It's like saying, what do I need to do to this denominator to get this one down here? Well, obviously, it is missing the y minus 2. So I'd have to multiply y minus 2 down here and y minus 2 up here, and that would mean I'd have a 3y minus 6. So you put a 3y minus 6. Okay. Now, look at the second fraction. What denominator, or what do I need to do to this fraction to get this LCD? Well, it's obviously missing the plus 3 down here. So I need to put a y plus 3. Y plus 3, top and bottom. Now check this out, guys. Instead of modifying the second fraction and rewriting my entire second fraction, I'm going to do this. I'm going to take the minus 2, the negative 2, and distribute it, giving me a negative 2y, and distribute it, giving me a negative 6. Okay. Now, what does that do? And notice I wrote it all on top of the same LCD. What that does is just saves me some time from writing the denominator twice. What is 3y take away 2y? That's 1y. And what is negative 6 take away 6? That's minus 12. So our answer really is y minus 12 over that LCD, y minus 4, y plus 3, and y minus 2. So I don't know, this might confuse you, right? If it's confusing you, don't do it. If you're like, oh, that's a nice way to save a little bit of time, then go for it, all right? But what I would like to do is go back to the initial method of doing this. Here's our answer. Let me put it on the side. This is what we were doing. This is what we have been doing. We've been modifying both fractions to look like these new LCDs, right? So again, what's missing from here to get to here? Obviously the y minus 2. So when I distribute up there, I'll get the same 3y minus 6. And then over here, what's missing from the blue binomials to these three binomials? It's missing the red y plus 3, y plus 3. So if I were doing it as the original way we would do these, just rewriting it with the minus sign in between, then I would just be distributing the 2 times y, that'd be a 2y, 2 times 3, that would be a 6. And then, now that I have a common denominator, I would write it twice. I would write it once and then combine the numerators. So 3y minus 2y, that would be 1y. There's our answer. And then minus 6, that'd be a minus 12 over the LCD. You get the same answer, it's just done without writing the second fraction's denominators again. So it's totally up to you. If you understand this original method better, please stick to the original method, all right? Just wanted to show you guys a way to shave off a couple of seconds when you do this problem. Let's move on. We now need to talk about graphing reciprocal functions. This is the last part of the quiz. It's probably the biggest part of the quiz because this is the new stuff that we've been doing this week, right? Adding, subtracting, multiplying simplifying. That's all from previous weeks. We've been graphing reciprocal functions, so this is the majority of the quiz. Of course, there will be spiral review of the other stuff that we just covered right now. But let's begin. We have this f of x function, and let's start by asking this question: which quadrants will the above graph never touch? So I'm going to give you guys a couple of seconds right now. I'm going to pause it, and you guys go ahead and post on the comments, what quadrant do you believe this will never touch or cross through or be on, right? Will it be quadrant 1, quadrant 2, quadrant 3, or quadrant 4? Ladies and gentlemen, in order for us to really understand what this looks like, we need to understand what the a value is, the h and the k, and how it affects the parent graph, technically throughout the transformation, so you can know what it ends up looking like. So let's first begin by writing our reciprocal function setup. We have y equals, you usually have a 1 over x minus h plus k. Now, the a value might be written out here being multiplied in front of the fraction, or it could also be just placed up here, okay? So it depends on how the function is presented to you. So in this case, you could clearly see that there's a -3 up there instead of a 1. What does that really mean? That it gets reflected over the x-axis, and then there's a vertical stretch of 3. Then after that, it shifts 2 to the right and 4 up, okay? What the heck? All right, those are the transformations, and we'll get to transformations in a little while. But right now, let's begin with the most important part of visualizing this reciprocal function graph. The most important part is identifying your asymptotes. Okay, so the asymptotes will be x equals h and y equals k. The actual equations, x equals h, that'll produce a vertical line, and the equation y equals k, that'll produce a horizontal line. So what we have here is x equals +2 and y equals +4, okay? And when we look at that graph, if we started sketching it, we're going to go to +2 on the x. So we have 1, 2. You get the vertical line right there. And then we have the +4 on the y. 1, 2, 3, 4. Get the horizontal line right there. And at this moment, let's pause to know where our graph is going to be at. Let's reflect on the original parent graph. The parent graph is f of x equals 1 over x. And we should all remember that that produces this graph. Wow, that's ugly. But yeah, you get the idea. It's in quadrant 3. And this one over here, quadrant 1. With the asymptotes being at x equals 0 and y equals 0. Now, what would happen if I were to throw a negative sign into the a value? That would cause a reflection over the x-axis. Okay? So if I did, let me actually do it over here. Looked at the function f of x equals -1 over x. It would reflect over the x-axis. It would no longer be on the lower left. It would be on the upper left. And it would no longer be on the upper right. It will be on the lower right. That causes a reflection over the x-axis. So what do we know so far? We know that this graph is negative, which causes a reflection, which is upper left and lower right. Instead of lower left and upper right, it's upper left and lower right. So it's still going to be upper left and lower right. Yeah, it gets vertically stretched by 3, but we don't really have to be accurate with that. Here it is. There it is. There's my amazingly accurate sketch of f of x equals -3 over x minus 2 plus 4. So which quadrant does it never touch? Well, here's quadrant 1. There's definitely part of it right there and right there. Definitely goes through quadrant 2. It does not ever touch quadrant 3. Quadrant 4, absolutely. We could see that graph going right there in quadrant 4. So I hope that we understand this, and let's say you don't, technically, I guess nobody could stop you from using Desmos to graph it, right? Which is kind of like cheating. Anyway, probably shouldn't have mentioned that on the video. What else are we going to have? Final thing we have is describe the transformations from the original parent graph to this graph, right? Now, this is the one we just graphed, but it's this simple. You always start with your A value. If the A value is negative, you say that it reflects over the x-axis. And also, if your A value is a value bigger than 1, you say that it gets vertically stretched by 3. And that's your second transformation. And obviously, your third transformation are your shifts, that it shifts 2 units to the right and 4 up. Okay, and that's based off of your H and K. And like always, think opposite on H and take K for what it is. So with that said, we have covered pretty much everything or every topic that will be on tomorrow's quiz.